Hello and welcome to this episode of the Smooth Scaling Podcast, where we interview industry experts to really understand how to design, build, and run scalable and resilient systems with the ultimate goal of providing great user experience. I'm your host, José Quaresma, and today I'm joined by Moji, a distinguished product architect at Qt, to talk about why simple is scalable. We really talk about kind of broader non-scalability and how we see that, how Moji sees that, and we deep dive specifically on simplicity and why that is such an important part of scalability, not only from an architectural perspective, but also looking at software development itself, but also around processes and how to run an organization. Moji, welcome to the podcast.
Thank you, Jose. Nice to be here.
Super good to have you. So you started in Qt around 10 years ago, is that right?
Yeah, it just feels so.
Yeah? Can you tell us a little bit about your background, how you got to Qt, and maybe a little bit of the journey?
I have been in this industry, programmers, kind of like software technology lasts probably now 18 years or so. Mm-hmm. I was doing some tools development at that time back in Iran. I think, it's 18 years ago now. And then I was in Finland doing some programming there and doing my master's there. And then I started working at Qt 10 years ago. At that point, when I joined, we were pretty few, actually 10, 15. Mm-hmm. And now we are 200, almost. And I'm enjoying this ride with great colleagues like you.
Thank you. And maybe getting started, right? Because we're talking about scalability, and that's a big theme for our podcast. Can you tell us, how do you see scalability? How do you see, what are for you the key factors of a scalable system?
When you have a simple system, you can scale it pretty fast and pretty reliably. And kind of like makes sense. Even if you want to look at the whole textbook, the CAP theorem. Mm-hmm. In the CAP theorem, you have three factors: availability, consistency, and then network partition. Mm-hmm. You cannot have all of them together. Imagine kind of consider simplicity, that you want to have everything. It's not simple, so you need to choose between them. And then usually when you want to have a scalable system, people go for availability and network partitioning. Mm-hmm. So they let the consistency go away and system be eventual consistency. So that is one of them. Then we can go down of this, go further down on the simplicity one. Another factor would be that, okay, when you are doing this, you are creating the system. Just make it less dependent on the other systems. So again, we are talking about simplicity, a simple system that doesn't need other systems. So it doesn't need network, it doesn't need I/O, it just itself as a component is self-sufficient. We can continue this kind of like a topic. Again, under simplicity, don't have too many background calls, you would say, Just make it simple, get the requests, do your logic response back. So not much of this background task. And then there are other factors also. I don't know if you want to consider them simple or not, but could be that don't block the request. When you are supposed to have a high throughput, and at Qt we do like millions per minute. Mm-hmm. So you need to get the request. Don't block the users, respond as fast as possible. And the final thing, I don't know if you consider it simple or not, maybe not simple, but not part of the system, but part of your process. Always do load testing and always have some kind of measure that's how your system reacts on the load.
Would you say that simplicity is inherently better? Is there any scenarios where simplicity is maybe not the way to go?
I would say that yes, it is the best solution. I am usually not that much, 100% this side or that side, but related to simplicity, I would say yes. Let's talk about some specific scenario. You get the request, you want to have some states, But let's make it simple, not have that state on the server side. Just make your server stateless. That is again a simple system. if we would be able to live in a dashboard that or system just not depend on anything, not having any state, and just do logic fast without blocking, the simplest system probably it would be able to scale really good.
But and when you mentioned kind of having the stateless system, at least at that level, but you still need to keep state somewhere. So are you just kind of moving the bottleneck or the concern further down the stack? How do you balance
Exactly.
that?
That's a good question. Yeah, this is again the trade-offs.
Yeah.
Do I need a state? Yes, we are not living in a dashboard, so
Yeah.
everything kind of. But what about if we put some stuff on the client side? What about if we hash the data? And sure, when you are putting some information on the client side, then you need to think about the whole security, encryption, and all those. So can you trust that? But yeah, there is ways to do that one. And then, okay, now I need something on the server side. But does it need to be a database? And if it's a database, what kind of database? Does it need to be a consistent database? Yeah, it should be a SQL database, or you can use the NoSQL database. At Qt specifically, yeah, we try to use the most scalable NoSQL database. Now I can say one of the best one is DynamoDB from AWS. This is pretty good at scaling fast and pretty reliable. So I would use that one as well. Sure, you are right. We cannot always keep that motto that, we want something pretty simple. Don't depend on anything.
Yeah.
But you need to keep it in your mind and wisely choose the stuff.
Maybe get back to more broader scalability part, but still on the simplicity side. So do you have any specific guidance or tips for teams that are trying to bring simplicity into their system design?
Right. Yeah. If I want to think about it, I go back to how I started. Yeah. About dependency. Dependency is one of the factors. Does really your component need to communicate to, 10 different other services? Can you make it just 4? In software world, in an architecture world, we have this coupling and cohesion. Yeah. Although your system needs to have a less coupling to other, but also it needs to be self-sufficient and high cohesion as well. So maybe that service that you want to design maybe can be divided in 2, and one of them maybe doesn't need to communicate to a lot of other systems. The other one needs it, so we keep that, but kind of like by modularization and kind of like making it decoupled from each other. But some word sounds a little bit controversial. I'm also on the side that you need to keep simplicity doesn't mean that the system is really small or your service is small. I don't agree with people that, your service needs to be just one line of code. No, that's not the real world. Yeah. But the dependency can be minimized. Even in some scenario, if you put some logic in one system, then you don't need to call another system would be a good. Yeah. Do you want to give a sample on that one? Actually,
Yeah.
Imagine the database part that we discussed, the state part. Yeah. I can go directly and call another service as, a Redis cache or another database, but also I can use a memory cache on my service as well. In this scenario, I'm coupling my system with a memory cache. However, what I'm doing here regarding to scalability, I'm keeping my system less dependent on the other services. So when I want to scale, I'm just scaling this service, not the other service. That is a good part of it. Yeah.
And are we touching a little bit on I guess there's a scale from maybe one monolith for your whole system and everything is a one-line microservices, right? And maybe and there's big variation in between, right? So it feels like you're touching a bit on that trade-off, right? That of course, if you have everything in a monolith, there's no dependencies because everything is in there, right? But if you go to the other extreme, then you're simplifying each service, but then you're adding a lot of dependencies. Is that?
That's 100%. You are on the point. Yeah, it is a big war over there. Okay, somebody's I think it's kind of like a dialectic process. Yeah, in the old time, everybody wanted everything in one monolithic system, and then gradually the other group came. Everything needs to be as simple as. I was reading some text that every line should be a service. But to be realistic, I think something in the middle. And now I can see actually gradually people are understanding that maybe we are going too far toward that microservices. Yeah, finding that sweet spot between probably would be the best because of the point of failure. That is another thing. We talk about simplicity, less dependency, easier to scale, but also there is point of failure. Now, if I'm depending on 10 different services, actually, I have 10 point of failure in my system and I need to scale 10 different services at the same time. Yes.
Yeah. With a lot of services, then you're also adding some complexity with dependencies on when you're making updates to one of the services and how you, I guess, handle
True.
all those and updating all of them, and maybe how do you kind of orchestrate those changes, right? So you're also adding complexity there.
You have a point there. Yeah, the simplicity is not just toward the scaling part, also about the process part, the development time, deployment, all those stuff, and also monitoring as well. I didn't touch monitoring. Maybe later we will talk about that one because a scalable system, you need to have a good monitoring. Yeah. In this scenario, you need to monitor 10 different services at the same time. And kind of like, as you mentioned, the best word, orchestrating between the services is not an easy task, actually. So finding that sweet spot, I would say, is the best one, to not be, a giant service and not be really small without cohesion. And if we back to that coupling and cohesion, your service needs to be small, but small enough, not too small, because then you will lose the cohesion as well.
I like that. And and so maybe kind of going back a little bit up from simplicity more towards scalability as a whole, right? We in Qubit, we work across a lot of industries, probably all the industries out there, at least close to that. Are there some patterns, some characteristics of scalable systems that you see are common or shared across those industries?
Yes, at least for us, is we have one system. Yeah, we have one system that, as you mentioned, works in different industry. Even our system with the other people's systems that they might have, a online shop. They might have something that fights with the bots that get a lot of requests. Yeah, all those systems, they need to be scalable like us because we are getting huge traffic. They need to be able to handle huge traffic. If it's a Black Friday, then there is online shop. They will get huge traffic. They need to scale as well. So for sure, we have a lot of kind of like a similarity. And again, back to that one, that simplicity one, less dependency, and making it kind of like a self-sufficient services that does not depend on too many other services. I would say that for them would be the same kind of like a concern as what we have here.
Continuing on in the theme of kind of Qubit and how we do things, is there any specific examples, and it could be in the last year or maybe from 10 years ago, where you see kind of that we either had to adapt and make things simpler, or maybe even did we have some cases where we went kind of a bit towards the extreme and made things too simple and actually had to backtrack? Do you have any?
Yeah, I don't know if it's exactly what you want to hear, but it's kind of like one of the scenario we had. We had, again, it's more toward that monolithics, microservices and stuff like that. We had this engine that was thinking about how a waiting room or a queue needs to behave, from logical when it's to the start, what condition it has, all those logic. And we had some logic related to how this waiting room should look like. Yeah, we call it at Qubit Custom Team, the presentation layer. And then we started to say, okay, guys, this is two different responsibility. Really, should we separate them maybe? And then we did that one. That was pretty cool. We could create two modules. People could deploy it, develop it and deploy it separately. Nice stuff. But then at some point we added a lot of other components. Yeah, we use another third-party tool to be able to manage these flags and stuff like that. What feature is enabled and not on that presentation part of it. And then suddenly we saw we are in production and that service is not answering fast enough. So we depend on another service Then we decided now that doesn't work. So we came back. So we separated these two, presentation and logic layer. But on the presentation layer, we didn't depend on the another service. We just create that one and put it part of that service to be able to handle those feature managements.
Okay.
But we kind of like paid the price. I remember that time that I look at this one and say, okay, we need to do a big load test, and during that load test, we kind of like figured out that doesn't work. So we went back, we did reiterate on that development, and then the project was kind of like delayed for a month, but it's worth it.
Yeah.
I would say, yeah.
And do you have? Because I think talking about examples is really great. Do you have other examples of kind of where you see that complexity became problematic? Can you think of something in that area?
With the complexity part, I'm just totally, when you say complexity, my mind goes to the dependency. I'm trying to figure it out another way of complexity. Yeah. Maybe the logical part. Yeah. Kind of like, I would say, maybe generic. I cannot recall it, but I see it daily in the development. Yeah, we engineers, we are pretty good at over engineering stuff. Yeah, sometimes they tell us this and we are accused of this one. But actually, that's true. Yeah, in the daily task, in the daily at QIT, or, when I'm talking to my fellow engineers, my friends and colleagues, and then they try to design. We wanted to find a bug, or we wanted to understand why the specific scenario happens. And I was talking to one of my colleagues and friends here, and then he created a really nice, complex system with really nice, good architecture. Then we sit down and say, really, do we need that one? Yeah. We want to develop a small code to be able to handle a specific scenario. Do I need 10 components? Do I need to put this total modularity and stuff? Actually, at the end, we ended up to make the whole development process 1/10 of the time that we wanted to do. And also, I would say that resiliency for that piece of code, resiliency was not really important because it was a code that we wanted to see how this works. It was more on a POC level and the agnostic part, but the whole development reduced pretty high on that one. So back to, I said I told you a long story, but back to your question, yeah. I see complexity as a way of over engineering quite a lot daily in my task.
Yeah, that sounds like it's you're also kind of your mindset. You're thinking about complexity on the other hand, simplicity, not only on an architecture and development, but also in terms of processes and
100%.
I guess leading teams as well. Do you have?
Yeah, it's just like I would say that I'm kind of like accused of the person not being really process oriented generally. That's one. Yeah. But for me, is that, really nice to have processes is something that I also learned, coming from a startup at QIT that is like 10 people and you work together every day, and then now 200 plus. And so you need the process. But at the same time, you can see sometimes, making it too complex processes. You will kill the whole innovation part. And also you make the whole development time pretty lengthy process as well. Yeah. You need to have 10 different meetings with your guys. Let's sit down. Let's have a whiteboard. Let's draw it there, and just simply let's talk the business. Yeah, it's not even about technical stuff. I have been in a meeting related to the product features, even in the sales talk. Yeah, when it gets technical and I need to attend on those, and I could see that all this, talking about different stuff and complex stuff actually make the process pretty lengthy.
Yeah,
and fragile, I would say.
It's I guess it's back to trade-offs, right? So it's back to maybe not over-engineered, but not having it
too loose,
or maybe not even there. That I think that's some of the growth pains that you encounter when growing.
Also case by case, yeah. In some scenarios, as I mentioned, if it's a POC project, maybe too loose is fine. Maybe the speed for you is important. That trade-off, I think it's something that we engineer needs to learn about that one better. At least we need to practice that one better.
Yeah. I was thinking maybe we should go into some rapid fire questions that we have.
Somebody help me.
Just answer what comes to mind. Keep it short. It's
is it GDPR compliance?
We will well, hopefully GDPR. I think depends don't know if you will share any personal or data or PII data.
Okay, cool.
Hopefully not.
No IPs.
No IPs. First question: scalability is
Simplicity.
simplicity. There we go. Another question is: is there any kind of resource that you would recommend to the listeners? I mean, any kind of book, podcast, blog, or kind of person that inspires you, that you follow? Is there anything that kind of within this area of simplicity and scalability, anything that you would recommend?
I think it's a little bit older school, but Martin Fowler was one of them that I always was, were looking at that one, that I were looking at him usually, but mainly also learning by looking around. Yeah, being is kind of like a critical thinking, I think always will help. Not just following, following whatever is the hype in the engineering world. It's more like asking question that, okay, does it make the system scalable in a specific scenario? Is it the best practice? Can I adopt it in my industry? Yeah, there are all these specific trait for every industry or every application, and then you need to get that one and customize it.
Yeah.
I try to keep my answer short, so sorry.
No, that was good, and I have a feeling that maybe you already replied to the third one, which is, but maybe not. What advice would you give to yourself early in your career? So, if you could talk to you 15 years ago, or for any listeners that might be listening that are kind of maybe starting or growing in this area.
I can, I go one step back. Yeah, I came, the first industry I was working, it was heavily data-oriented application. It was related to the insurance back in Iran. I was working in a great company. They were providing this software for insurance company. At there, the data needs to be consistent always. Yeah. It's no, it's not okay, eventual consistency and stuff now. And then I came to Qt, and then, I was working with a great mind here. And then I was introduced to this kind of like eventual consistency, more and more scalability, pretty hard, I would say. No, I learned pretty nice. I would say that, but always kind of like comparing and not just following whatever is a trend. I would say that is the best. And I think it would pay off, actually. Yeah. For sure, you might be a little bit hard time convincing people that this trend that is everywhere is the best trend. But I would say that in the real scenario, people will see and recognize it that, that was a good idea, that we needed to go more deep instead of just following. Right?
Last question, Moji.
Sure.
Is there any technology that excites you these days?
Everybody is talking about AI, yeah? No, for me it's more like I like the stuff related to this geographical kind of like a distribution, data consistency, eventual consistency.
Yep.
Yeah. I would like to see these databases, NoSQL specifically, that can be distributed easily.
Yeah.
And all those stuff related. I know it's an old topic, but it's kind of like interesting for me that how fast the data can be distributed. And for us at Qt, it's pretty important. We are working on this to be able to have this distributed system across data centers. We are thinking about that one, and that is a pretty interesting topic for us, I would say.
Very cool. And that might be, I think that topic could be one that we might want to revisit at some point later in this podcast. Yeah. So maybe we'll have that as an excuse to have you back.
For sure, I would enjoy it. I can see you.
Awesome.
Always.
Thank you so much, Moji.
Thank you.
And that's it for this episode of the Smooth Scaling Podcast. Thank you so much for listening. If you enjoyed, consider subscribing and perhaps share it with a friend or colleague. If you want to share any thoughts or comments with us, send them to smoothscaling@qit.com. This podcast is researched by Joseph Thwaites, produced by Perseo Mandilo, and brought to you by Qt, your virtual waiting room partner. I'm your host, Jose Quaresma. Until next time, keep it smooth, keep it scalable.